Okay, we are getting to the fun parts of quadratics. We are going to solve them. So 3.1, solving quadratics. And there's a few different ways, of course, you can solve a quadratic, but let's just review that when you solve a quadratic, so solving a quadratic means you are finding the roots, also known as what we've been talking about, right? Those x-intercepts. Kind of ran out of room there. All right, so when you're solving, you are looking for these roots. And the ways that we are going to talk about solving a quadratic today, of course, so far we've been graphing. We've had our graphic organizers, we've been graphing them, and then we look for where it crosses the x-axis. And so far, they've been integers. So far, we've been able to know our roots just from graphing. However, as you know, I already used that color, I'll do pink. As you know, we can sometimes have irrational or fraction answers. So a method that we could use is that we could use square roots. And we use square roots when it's in the form x squared plus c equals 0 or x minus a squared plus c equals 0. I guess I should have put h and k's there, but in those two forms, it's the idea that this square is isolated. And then we have the method that we started yesterday, is that we could factor the quadratic and use the zero product property. And that zero product property states that if you have two or more things that are multiplied together, so you have a products that equal 0, well then either this A has to equal 0 or this b has to equal 0. That's the only way this equation would equal 0. So we would say a equals 0 or b equals 0, right? Two things multiplied together equals 0, then one of them has to be 0. So let's start here with factoring. I think that's the best place. We'll stay here. So we're talking about examples for factoring. We'll label it. We are going to be factoring. And our example number 1 is x squared minus 4x equals 45. Now, as a reminder, let me jump back to this purple set. As a reminder, set equal to 0 first. So the very first step that you need to do is set equal to 0, meaning that in this equation we need to subtract 45 from both sides. So x squared minus 4x minus 45 is equal to 0. Very first step on that one. And now it's time to factor. And you can either set up your diamond, or I would highly suggest that you get used to just factoring by figuring out the two first things that can multiply together. And then for this one, it's going to be a -9 and a +5. That will get us a combination of -45 and -4x. And now I have these two products. So now I have x minus 9, and then our other product is this x plus 5. So we set both of these products equal to 0. So x minus 9 equals 0 and x plus 5 equals 0. From here, they're both linear, so you can use inverse operations to solve. So you have to subtract 9 from both sides. Excuse me, you have to add 9 to both sides, and you have to subtract 5 from both sides, so that your two answers are x is equal to 9, and x is equal to -5. Let's try it again with a little bit of a more difficult one. Stick with blue though. So we have example 2. Might have something like 3x squared is equal to 5x plus 2. First step is set equal to 0, and then subtract 2, subtract 2. So our equation is 3x squared minus 5x minus 2 is equal to 0. And now it's time to factor. And if you can't do it on your head, you are more than welcome to set up those little diamonds on the side. For this one, it would be -6 and -5. So your two goal numbers are -3, excuse me, it's definitely not -6 and +1. Sorry, it's a little late at night. So that we have 3x plus 1 and x minus 2. That should get to our two goal numbers right here. And then set up those two factors. So 3x plus 1 and x minus 2. Those are the two things that you need to set up. Equals to 0, x minus 2 equals 0. So you still need to use your inverse operations. A lot of times you just see that people choose the opposite signs. That's not correct, right? You need to say that x is equal to -1/3 and x is equal to 2. So those are the spots that this is crossing the x-axis at -1/3 and 2. Okay, and just as a reminder with your graphing ones, you do always want to look for your GCF just to make it a little bit easier for you. Throw one more example on here for you. Example 3, just a quick one. 6x squared minus 18x plus 12 is equal to 0. And I just want to show you that when you pull out your 6 here as your GCF, so x squared minus 3x plus 2 equals 0, that this becomes a whole lot easier to factor. So x minus 2 and x minus 1. And you don't even have to worry about this 6 when you're setting it up because you only want your linear equations. So x minus 2 equals 0, x minus 1 equals 0. And when you add 2, you get x equals 2. And then you need to add 1 for x equals 1. So just an FYI on that one. Always look for that GCF. It makes it easier for you. Okay, let's move on to our square roots. So square roots. And we need to take some time to do a little bit of a radical review. What I mean by that is that we need to simplify some radicals. So as a reminder, you might have something like the square root of 49. And this little square root sign says, well, what times itself gives you the inside, or the 49? And you would say, well, 7 times 7 equals 49. So the square root of 49 is 7. Now, sometimes they don't have nice even numbers that they work with, or nice whole numbers. So the square root of 32. And you would say, well, I don't know what times itself gets you 32, but you can break it down a little bit more. And we can say that 16 times 2 is 32. And we care about this one because 16 is a perfect square. So we take that 16 out of the radical, and 16 square rooted is 4. So we say 4 root 2. And we just want to remember to simplify those guys. So 4 root 2. Let's try one more here, which is the square root. Actually, I'm going to use my paper that I have from, I'm going to move this up a little bit. The square root of 72. Now, let's just pretend that you don't see right away that 72 can be divided by 36. Let's say that you break this down into 9 times 8. That's totally fine because you can bring this out and you can say, well, 3 times the square root of 8, but please notice that 8 can be broken down a little bit more. And we could say 3 square root 4 times 2. When you bring the 4 out, it turns into a 2, and 3 times 2 is 6 square root 2, and now you have your final simplified version of this. So just a little review on those radicals before we get started. Now let's use those radicals to solve these square roots. So we are on example 4, and we can use these square roots in something like 4x squared minus 31 is equal to 49. So your first step is that you need to isolate the square. Isolate the square. And the number one thing I see people do, switch over to this bright yellow, number one thing I see them do is not actually isolate it. So the only thing that we care about here is x squared, meaning that we have to add 31 to both sides, getting 4x squared is equal to 80. And again, from here, you want to isolate. So in order to isolate that square, you need to divide by 4, x squared is equal to 20. And now you're going to take the square root, I'll even switch signs here, square root of both sides. And when that happens, you get x is equal to plus or minus, don't forget that plus or minus, and we're going to simplify the square root of 20. 20 can now become 2 square root 5. If you can't see that right away, please see that 4 times 5 is 20. All right, so I'm just going to put another reminder. I went over really quick on that one, but don't forget your plus or minus. Don't forget your plus or minus on that one. And it's because when you take the square root of something as a tool, you either have the positive, negative, or the positive version or the negative version of it. It's kind of like saying, I always throw this example up here on the board, so I'll put it on the side, which is that it's kind of like saying x squared is equal to 36, and we have to figure out, okay, what's the two options squared that get you 36? And the first one that we know, we're like, well, x6 squared gets you 36, but that other reminder of negative 6 also gets you 36. So that plus or minus is really important. Don't forget about that one. Last example, I promise. Very last example, and that is that sometimes you will have a square root that's isolated, and it looks like vertex form. So we're going to throw something up here that looks very similar to vertex form. For example here, this 2 times x minus 4 squared minus 10. So you could graph this, right? You would say, well, I'm going to go to the right 4 and then down 10, start my vertex, stretch of 2. But now let's figure out where it crosses the x-axis. So you first need to isolate that square. And that square for this one is x minus 4 squared. So add 10 to both sides. 2 times x minus 4 squared equals 10. And then divide by 2 because you still have not isolated the square yet. So x minus 4 squared equals 5. All right, now that the square is isolated, now you can go ahead and you can take the square root of both sides. So you get x minus 4 is equal to plus or minus the square root of 5. Don't forget those plus or minus. The last little step that you have to do with these is that you have to move that constant over. So x is equal to 4 plus or minus the square root of 5. We're going to box this, and what this means is that x is going to cross the x-axis at 4 plus the square root of 5, and at 4 minus the square root of 5. So just some cool stuff on these quadratics. I'm going to make one last note. I know I promised you, but the last note, and this is about your radicals. is that sometimes you need to, so I'm going to say remember to rationalize the denominator. And I promise I won't make you do an example now, but we will have some that you'll need to do there. Great job. That is your first introduction to solving these quadratics.